Welcome back to the deep dive. We are cutting straight through the noise today. If you're running any kind of serious LLM pipeline right now, you know the bottleneck has shifted.
Oh, completely.
It's no longer about generation speed or, context window size. It's the evaluation crisis.
It's the silence after the generation is what I started calling it. We've gotten so good at generating tokens, text, code, whatever, at a massive scale.
Right.
But we're still, surprisingly bad at programmatically telling if any of it is actually high quality without a human in the loop.
Exactly. And just to set the stage here, we are not talking about diagram metrics. If you were still relying on BLU or Rouge for, I don't know, anything more complex in translation.
You're basically bringing a ruler to a debate competition. It's the wrong tool.
It really is. And we're also moving past the simple LLM as a judge status quo, which, let's be honest, is usually just a zero-shot GPT-4 prompt asking for a score from 1 to 10.
Which is just falling apart under real scrutiny. We're seeing major papers now highlighting how fragile a single model judge really is. Which brings us to today's focus.
The paper, When AIs Judge AIs.
Exactly. We're going to tear apart this architectural shift from single judges to multi-agent debate frameworks and then ultimately to process supervision agents.
So we'll dig into the architectures, chat eval, debate, court eval, Meiji eval. We're going to break down the compute trade-offs, the bias, all of it.
And the meta-evaluation problems, which is a whole other can of worms.
So assuming everyone listening knows their way around a standard RLHF pipeline, let's jump in. Why is the status quo failing?
Okay, so to get why we even need these multi-agent systems, you have to really understand why the single judge, the point-wise or pairwise model, just fails. It's not just about, getting different answers sometimes.
No, it's structural.
It's a structural blindness.
The paper calls out verbosity bias. I see this constantly in production. You fine-tune a judge, and it just starts thinking long means comprehensive.
Exactly. And the self-model bias is even more, I think, insidious. Liang et al. Showed this really clearly. A GPT-4 judge has a statistically significant preference for GPT-4 outputs.
It just likes its own cooking.
It recognizes its own voice, its own patterns, and just rates it higher. But the most damning one, for me, is the adversarial gaming.
The Zhang et al. Findings on the null response attack. This is basically prompt injection for evaluators.
Right. They showed you can feed a judge this high perplexity, nonsensical text, but if you style it confidently, you can trick a single judge into giving it a high score.
It's the LLM version of a buffer overflow.
It is. It proves the judge isn't reasoning, it's just pattern matching.
Which is terrifying if you're using that judge to filter training data for your next model.
Yeah.
You're poisoning your own well.
And that's why the industry is moving from individuals to committees, which brings us to the first big architectural leap, Chevreul.
Now, a lot of people just think this is majority voting.
And that's the biggest misconception. The paper is really clear on this. If you just spin up 5 instances of the same model, say 5 generic helpful assistants, you get 0 gain.
You just amplify the bias.
Exactly. It's ensemble modeling 101. You need uncorrelated errors.
So the key isn't the number of agents.
It's the diversity of personas. That's the main hyperparameter you're tuning. You need distinct roles. One agent checks syntax, one checks for toxicity, another for creativity.
And when you force that role-based diversity,
that's when you see the gains. Chat with Zia showed, a 10 to 16% improvement in correlation with human judgment on open-ended QA?
That's a decent lift for sure. But I feel like it still suffers from what I call the politeness failure. Even with different roles, these models are all RLHFD to be agreeable. A committee can just devolve into everyone nodding at each other.
They don't want to step on each other's toes.
Which is why I think the debate architecture is the real inflection point here.
The adversarial triad, yes.
Right.
This is where we move from consensus to conflict. Debate isn't about voting.
It's about stress testing.
It is. You have 3 really rigid roles: the scorer, the commander, and the critic.
And the critic is the game changer. It's basically a red team agent in the loop.
Yes. The critic is explicitly prompted to find faults. It has to attack the scorer's rating. This is what breaks that inherent limit of single judge bias.
Because it forces the scorer to generate a whole chain of thought defense.
Right. You're basically operationalizing the scientific method inside the inference loop. Thesis, antithesis.
Antithesis. You're forcing the model to hallucinate its own counterargument and then refute it.
And if you take that structure and formalize it even more, you get to courtival.
The legal metaphor.
Right. A judge, a prosecutor, and a defense attorney.
I've looked at the workflow for this, and it's surprisingly rigid. The grader gives a score. The prosecutor attacks specific logical fallacies.
The defender has to rebut by citing the source text.
And only then does the grader get to revise its score.
It models real-world deliberation, and the results on SumEval and Topical Chat were pretty significant. It just prevents the lazy judge problem. The judge can't just skim anymore.
Okay, but I have to play the skeptic here on the engineering side. Scaling this seems like a complete nightmare.
How so?
Well, if I'm evaluating a general-purpose assistant, am I supposed to handcraft a prosecutor prompt for every single possible domain? You are an expert in Python errors. Then you are an expert in 18th century poetry.
The prompt engineering overhead.
It feels like it would totally negate the automation gain.
And you've hit on exactly why MayJ-Eval was proposed. The multi-agent as judge evaluation, it's designed to solve that ad hoc persona bottleneck.
So how does it handle the prompt generation?
It automates it. It's a two-step pipeline. First, it ingests domain docs, so clinical guidelines, API docs, or whatever. It uses an LLM to extract the evaluation dimensions from that text.
So it reads the documentation to figure out what good even looks like in that context.
Exactly. It builds the rubric on the fly. And then for step 2, it constructs the stakeholders. So if the domain is medical diagnosis, it automatically spins up a clinician agent and a patient agent.
So it removes the human prompt engineer from the loop.
Almost entirely.
That's a huge step. But we're still talking about text, evaluating text. The paper then makes this hard pivot to agent as a judge, which they distinguish from these multi-agent judges.
And that distinction is critical, especially for anyone working on autonomous agents.
This is the shift from outcome supervision to process supervision.
Precisely. If you're evaluating a coding agent or a web nav agent, the final string of text is almost meaningless. You have to evaluate the trajectory.
You have to see the work.
Right. And in the agent as a judge framework, the judge is itself an agent with tools. It has memory. It can execute code. It can make API calls. It watches the entire action log of the agent it's teaching.
The DevEI benchmark case study in the paper, the numbers here are just staggering.
They really are. DevAI has these 55 realistic dev tasks, bug fixes, new features. A standard single LLM judge is terrible at this. It disagrees with human experts 31% of the time.
Because it just looks at the code and says, yep, that looks like valid Python syntax. 10 out of 10.
Even if the logic is completely broken. But the agent as a judge, it disagreed with the human majority vote only a 0.3% of the time.
0.3%. That's basically zero.
It's within the margin of error. It actually exceeded individual human evaluators in consistency.
And why? Because it didn't just read the code.
It ran the unit tests. It interpreted the error logs. It actually verified the fix functionally. It bridges that gap between, probabilistic text and deterministic verification.
So on paper, this sounds like the silver bullet. We just wrap everything in an agent judge loop. But let's talk about the bill, the compute cost.
The compute cost, yes,
Wow.
It's massive. Courteval is already about 3 times the token cost of a single judge.
And agent as a judge.
Because of tool execution compilation times, you're talking about tens of minutes per evaluation task.
Which kills it for any real-time application. You can't have a user wait 15 minutes for a safety check on a code snippet.
No way. It's incredibly valuable for offline evaluation, your nightly regression tests, your benchmark suites. But for a production inference pipeline, it's a huge bottleneck.
So there's a massive trade-off between fidelity and latency.
Always.
There's also this subtle issue with the meta-evaluation part. The paper validates all of this by showing high correlation with human data sets, right?
Yeah.
Like SumEval.
Right.
But isn't there a risk of circular reasoning there?
That is the gold standard trap. We assume human ratings are ground truth. But human raters, say on MTurk, have their own biases. They prefer assertive tones, they skim long texts.
So if our agent judge gets a 0.9 correlation with humans, it might just mean we've successfully taught it to mimic human errors.
Precisely. We're just overfitting to the benchmark. We're teaching the judge to pass the test, not to find the objective truth.
And in domains like law or medicine, that's actually a negative signal. High correlation with a non-expert human is not what you want.
Not at all.
Speaking of domains, let's quickly touch on the specific implementations. Medicine, law, education.
Medicine is really the standout use case for MayJ-Eval because you can separate the accuracy dimension from the empathy dimension.
Which is critical. A response can be clinically perfect, but totally incomprehensible to a patient.
Exactly. So the doctor persona checks for hallucinations. It's looking for that 500 milligram instead of 50 milligram error. Rouge would say that's 99% similar, but the patient is dead.
Right. And then the patient persona checks for readability and tone.
Exactly. For law, you have the agent's court simulation. The key there is evaluating the legal reasoning chain. Not just the verdict, but whether the precedent was cited and applied correctly.
Which means the judge needs tools. It has to be able to look up the case law.
It has to. And the education example with the child persona was fascinating.
How do you define age appropriate?
You can't, programmatically. But you can prompt an agent to simulate a third-grade reading level and flag words it doesn't understand. You're using its role-playing ability as a unit test for complexity.
So looking forward, the paper points to this flywheel effect. This seems to connect directly to all the work happening in self-play.
This is the endgame, evaluation-driven development. If your agent judge is high fidelity enough, especially one with tool access, you effectively have an infinite reward signal generator.
You remove the human labeling bottleneck from RLHF.
Completely.
Yeah.
The agent generates a solution, the agent judge critiques it, the agent refines it. You can generate millions of high-quality preference pairs automatically.
This sounds like the AlphaGo loop, but for general reasoning.
That's the goal. It's how we likely get to stronger models without just scraping more of the web.
But I want to close on the risk. The paper touches on it. Alignment drift.
This is a real concern. If you close that loop agent training agent without any human oversight, you risk the models optimizing for a metric that slowly diverges from actual human intent.
They start speaking their own language, basically.
Or valuing their own internal priorities. If the judge rewards conciseness too heavily, the models might drift towards some cryptic shorthand that's efficient for them but useless for us.
It's Goodhart's law on steroids. When a measure becomes a target, it ceases to be a good measure.
Especially when a super optimizer is hunting that target. Which is why we'll always need meta evaluation. We need humans to periodically audit the judges themselves. You can't automate oversight away completely.
So the big takeaway for everyone listening, if you're building agents, you need to be building judges. The vibe check era of evaluation is over.
You need adversarial debate in your evil pipeline. And if your agents write code, your judges better be able to run it.
And as always, keep an eye on your compute bill.
Always.
Thanks for joining us on this deep dive. We'll see you on the next one.